Hello guys, welcome to the Fusion. First we talk about ADITYA-L1. ADITYA-L1 is the first space-based observatory class Indian solar mission to study the sun. The spacecraft is planned to be placed in a hollow orbit around the Lagrangian point 1 L1 of the Sun-Earth system, which is about 1.5 million km from the Earth. A satellite placed in a hollow orbit around the L1 point has a major advantage for continuously viewing the sun without any occupational eclipse. This will provide a greater advantage of observing the solar activities continuously. The spacecraft carries 7 payloads to observe the photosphere, chromosphere, and the outermost layer of the sun, the corona using electromagnetic, and the particle detector using the spatial vantage point of L1. 4 payloads directly view the sun, and the remaining 3 payloads carry out of into study of particle and field at the Lagrangian point L1. The suite of ADITYA-L1 payload are expected to provide most crucial information to understand the problem of coronal heating, coronal mass injection, pre-flare and flare activities, and their characteristic dynamic of space weather, study to propagation of particle and field in the interplanetary medium etc. There are some science objectives. Understanding coronal heating and solar wind acceleration. Understanding initial of coronal mass ejection CME flare and near earth space weather. To understand coupling and dynamic of the solar atmosphere. To understand solar wind distribution and temperature entropy. There are some uniqueness of the mission. First time specially resolved solar disk in the near UV band. CME dynamic close to the solar disk from 1.05 solar radius and thereby providing information in the acceleration regime of CME which is not observed consistently. Onboard intelligence to detect CMES and solar flare for optimized observation and data volume directionally and in energy and entropy of solar wind using multidirectional observation. The ADITYA-L1 mission will be launched by Isro PSLV rocket from Satish Dhawan Space Center SHAR SDCS SHAR Sriharikota. Initially, the spacecraft will be launched in a low Earth orbit. Subsequently, the orbit will be made more elliptical and later the spacecraft will be launched toward the Lagrangian point L1 by using onboard propulsion. As the spacecraft travels toward L1, it will exit the Earth gravitational sphere of influence SOI. After exit from SOI, the cruise phase will start and subsequently the space will be injected into a large halo orbit around L1. The total travel time from L launch to L1 would take about 4 months for ADITYA-L1. The trajectory of ADITYA-L1 mission is shown in the figure above. Is ADITYA-L1 is a complete mission to study the sun? The obviously answer is no, which is not true for ADITYA-L1 but in general for any space mission. The reason is that due to limited mass, power and volume of a spacecraft that carries the scientific payload in space, only a limited set of instruments with limited capacity and can be sent on board the spacecraft. In case of ADITYA-L1, all the measurements will be made from the Lagrangian point L1. As an example, the various phenomena of the sun are multidirectional and therefore the directional distribution of energy of explosive and eruptive phenomena will be possible to study the ADITYA-L1 alone. Another Lagrangian point, as known as L5, is a good vantage point for studying the Earth-directed CME events and assessing the space weather. Also, the polar region of the sun are not well studied due to technology's challenge of achieving spacecraft orbit. For such study, the sun polar dynamic and magnetic field are believed to play an important role in driving the solar cycle. Further, the polarization measurement of solar radiation at different wavelengths are required to understand the various processes occurring in the sun around the sun. By the way, if you want more type of this video, then subscribe to the Fusion and humble request to like the video. Thank you.